This is the introductory video for scarfing the bulkheads, joining the pieces of ply together so that we get one sheet wide enough to loft up a 4 metre wide bulkhead. Now I did this footage a month ago when I was building the boat, and based on common wisdom we did the traditional method of scarfing, two bevels, there's a scarf here, ply ends up the same thickness, which is quite important, and minimal amount of finishing. So that's all well and good, but then building a prototype is all about learning from the experience and figuring out how you can do it more efficiently next time. And I think in this instance there are aspects I need to review about some of these really time-consuming parts of the build, which was okay for me because I'm not charging for my time, but if the boat builder was doing it, you really would have to consider, well, can we do it quicker and better? And I think given that these bulkheads are covered in glass in lots of places, super strong, I think we could consider doing away with the scarf and just butt joining it and glassing on the side. Maybe rebaiting back the ply and glassing. But even a build-up's not a big deal because I'm going to put 4mm ply on top of this with a veneer anyway. So it's all going to be covered. So it's just about the strength. I don't think I'll do it this way again. This will have to go up for review, and there'll be lots of parts of the processes that we will review and figure out how to what's the best option. Ultimately, if you're building a few of these, we're going to CNC cut the panels, all the plywood and everything like this. So all the stuff I'm showing you can be pretty much replaced by a machine. And but yes, until you come to trim it, the likes of that. I mean, the CNC is going to cut square edges, and we do talk bevels and things like that, and scarfing and stuff like that. So, you know, to CNC cut this, sure, you can give a file for the whole size of the bulkhead, but the reality is you've taken 120mm out of the middle of it here. So you kind of got to work that into it, and then there becomes an issue with the person doing the job, getting all those lines lining up properly. There's a lot of element for error there. So there are ways in which you can design or plan or do the engineering to maximise CNC production, and I think one of those would be to butt join these, fiberglass both sides, job done. So we're going to be scarfing up the plywood to do the bulkheads. Now, it's probably one of the bigger jobs when it comes to building the bulkheads, because not one piece of ply is big enough. You need to create a piece of ply pretty much the size of the bulkhead, which in this case is about 2.5 metres by 4 metres. To do that, you need to scarf the ply, whereby you create 2 tapers that allow you to join the ply together and not increase the width of the ply. So I do it by stacking up the ply, setting it each one back 120, because these are 12mm ply, so the general rule of thumb is 110. I draw a line along the length of each bit of ply, which I just haven't done the middle one, so quickly put that on there. Might best in a scribing gauge, but this works. Good enough, near enough. Move the ply forward. Break up the screw there, can't go anywhere. From the 120 of course. And you're ready to go. This way, when I run the plane along, I end up with an even angle, so that's the reverse image. When you flip the ply over, you'll get that nice tapered marrying twin edges that'll just continue the width of the ply along. Obviously the middle one, because there's 3 here, is going to have 2 taper on each end, but all of them need 1 taper, so we'll do 3 at once. So basically your power plane, and just this is a big noisy job. It's going to take me about 10 minutes, so I think we'll pause for now. So I've hit it with the planer with the blade at maximum depth and chewed it off pretty quickly. I've looked on YouTube to see if there's an easy way of doing this, and there's some pretty full-on ways of doing it with routers and all sorts of carry out. But
this is quickest and easiest. If you get it near enough, you know, the epoxy will fill in gaps if you get it a little bit higher. But the main thing is to take off enough material. Check pretty high spots with a tape, like that. Good thing about ply is it kind of gives you the topography with the lines of the laminate. Should be straight and parallel lines. And now's a good time just to reduce the depth of your plane and just go along and just get those lines perfectly parallel. I like to finish off long ways with a belt sander just to get it bang on, you know, that last little bit. But yeah, about the strength and getting that 12mm consistency. Gluing up these sheets. If you're building a boat by yourself, you really got to think about materials handling at a time. How the job's going to pan out and what's going to happen, what motions are going to need to be carried out. Once you've got glue mixed up in this Northland heat, it's a race to get it done, so you don't get a second chance. So you've got to have it all worked out. So what I've done is I've anchored the centre sheet with 2 pebbles. I've remarked my 120. So there's a 120 line down there, so I know where the other sheets are coming to. The other sheets, of course, I have to glue them up the wrong way. So that one's on the end where I can handle it. That one's leaning up against a post. And most importantly, I've got this acrylic sheet under there, so that when I glue it, it'll bond with the table. As you can see, my 3 sheets have now become 1 and are the size I need to make the bulk. Video. I've just used a bit of dunnage, a few bits of scrap slats of ply and timber, just on the join, clamp it down evenly, with screws, just spread the load a bit more as opposed to just putting screws on. But again, you're trying to make it as fair and even as possible, avoiding sewing. So that's splicing.